many sizes. Look at those little knobs. They're called dendritic spines. You can think of them as being like toes that are scattered all over. If the neurons didn't have so many toes, they wouldn't be able to get their job done. Dendritic spines may be small, but they are really important. Spines help neurons receive signals from other neurons.
You can understand this by remembering our space aliens. When a neuron alien wants to talk to the toe of the next alien, neuron aliens show friendship by giving tiny shocks to one another. Just one of those strange things.
But it's surprisingly similar for real neurons. An axon ripples a signal along its arm called a spike. When the spike gets to the end of the arm, it causes a chemical to jump across a special narrow gap that if that second neuron fires a spike, it can cause a chain of spikes to the whole set of neurons, and it just keeps going. These signals flowing between neurons are carrying your thoughts. You can think of them as being like trails on your mental pinball machine. By the way, this is the only place where neurons to the next. And there are a lot of synapses in your brain, 1 billion synapses.
How you think? Well, maybe it's more complicated. There's some chemistry involved, but you got the basics.
Yes, what's really interesting here, the more often a neuron shocks the next neuron, the stronger the synaptic connection becomes. Talk a lot. Real neurons are like that too. Neuroscientists have a saying, neurons that fire together, wire together. Wiring together means that a brain link is being created. Learning means creating a stronger brain link.
When you're first beginning to learn something, the brain links are weak. There may only be a few neurons linked together, and the spark between the neurons isn't very big. As you practice a new idea, the synaptic links get stronger. This means the sparks get bigger. You can get more neurons with stronger synapses. The brain links get bigger and better. More complicated ideas can make longer brain links. People sometimes think of brain links as if they were mouse paths in a forest. The more the mouse runs along the path, the wider the path gets. The easier it is to follow the path. The fact that paths in your brain change and grow is called neuroplasticity. This fancy word just means your neurons can change. That's why